This is a quick overview of the contents of the tutorials Real Space in Gravity Engine 2. So in these scenes, we're working in real-world units in some sense, either around Earth orbit or in the solar system or on the surface of the moon. And so it shows how to do that. And there's also a kind of cool display controller in this first scene, Earth orbit with map, where we have a second display controller which will show us satellite trajectories on a map. So we have two display views, and then we also have some satellites where we're using real-world data from two-line element sets taken from Celestrak. And we've set up the GS controller start time so that it's slightly after the time in which those orbits are defined. And so when we go ahead and press play, what we see in all its splendor are satellites moving around Earth. Notice that the Earth is rotating. And we also see a view of the satellite tracks on a 2D map of the Earth. And the other thing that's going on here is the initial rotation of the Earth is set appropriately for the gravity engine start time. So you can read in more detail about how all of that stuff is done by going into the GE documentation and clicking on this open documentation link on the right-hand side here. And that'll show you all of the details about that. So the second real-world example we have is pretty cool. Allows you to build the whole solar system. So there's this script called Solar System Builder. I'm just going to go ahead and say remove the system. And so if you look over in the right here, you have a choice of planets and moons, a whole bunch of stuff. You can pick each planet with a checkbox, and you can say how many moons you want for each planet. You can say what year, month, and day you want the initial configuration of the system to do. You can also, down here, add small bodies, and the details for how to do that are described in the documentation. You have to go to the JPL small body search and get the small body ID. And the cool thing about this is that it will actually, when you press Build System, it will make web requests to the Jet Propulsion Laboratory Horizon system and get the orbital elements for all the things you've told it you care about. So if we go ahead and click Build System, we'll see down here there's a whole bunch of requests that are getting made. We're only allowed one open request at a time. You will see some errors go by about setting textures in the editor, and they're all benign. What happens then is we have a solar system controller, and what we build is a hierarchy of controllers. So we have a solar system with the planets, and then we have a separate controller for the Earth and the Moon, a separate controller for Mars and its moons. And when we go ahead and press Run, we start off looking at the whole solar system. We also have the planets spinning at the correct rate. So right now, because we're moving the planets fairly quickly, Jupiter's going bonkers. And then if you press a function key and the number of a system, like function 5, that gets us to looking at the Jupiter system, and you can see all the planets in the Jupiter system. If we do function F4 for the fourth planet, we get Mars with Phobos and Deimos, probably saying that wrong. And as we go from system to system, for example, here's Saturn, the timescale is adjusted so it's a little more appropriate for those systems. So that gives you the whole solar system. The final example is a rocket launch system. So we'll just look at, let's do lunar ascent pitch table. So here we have two views. We have the moon with its correct radial size, and on the moon we have a lunar module, which has this ascent rocket script, which in this particular case, the steering is going to be table driven from pitch table from a table I computed offline. And when we press play, we're going to see two things. We're going to see on the right-hand side a kind of XY in the plane of the target orbit view of what's going on. So you can see the launch ascent, and in the other side, you're going to see the resulting orbit. So we can press space to get things going. You can see some information in the top left about the orbit. We can press 4 to speed things up. I'm going into a fairly flat pitch here. You can see the orbit of the ship as it's launching off the surface and the resulting orbit as it reaches burnout. In fact, it looks like it just skims the surface, so that's maybe not the best pitch table in the whole world. The other examples in this scene allow you to be manually controlling the pitch, so you can press keys to pitch up and pitch down, or you can use a steering law, all of which is described in more detail in the documents. And that's our super quick tour of what's in the RealSpace folder.